Welcome. In this session, we are going to continue. This is basically the part three of the project that we're currently working on, the loan approval prediction model that we're trying to take from just ordinary data set like this and turn that into a machine learning model that is served um, via web API, and users can interact with it, which is basically um, what end-to-end ML projects looks like. Now, what we've done so far is, okay, let's go into the project. This is the project directory. I'm going to seed into that and get my VS Code up. I'm going to get my VS Code up, and it's still coming up. So in the last one, we set up um, the ZenML pipeline, the entire pipeline for cleaning, for loading the data, for pre-processing, and for model training. And we ran, I think we ran the pipeline, and it worked for now. So we have a basic pipeline for a base model. And if we give that a spin again, I'm going to bring up my terminal, then drag that up here just so it's easier. Then I'm going to activate the virtual environment. So I'm going to say .venv slash, sorry, that's supposed to be backward slash. We are on command prompt backward slash activate. So that is going to activate the loan project virtual environment, which is this one here. And the next thing we do is um give give this one this pipeline a spin again and see if that still works. So we're just going to go what do we do? We're going to UV run pipeline.py, and if we run that, we should get our pipeline should run. And if yours does not run and there is an error and you really haven't changed anything, you probably should just do UV sync again, so it syncs up the entire thing and everything is up to date. Then you can give it another spin. So while we are waiting for this to come up, what we are going to do today, what we are going to be doing today is we are going to be writing the FastAPI part, where we take what is inside the pipeline and we try and deploy that, try and wrap that in a web API. So then after that, we can now come back and set up um, experiment tracking, where we do hyperparameter tuning, we make our model better. And if we are able to find, model hyperparameters that makes the model better, we just push that particular model. It is called champion in MLflow terminology. So we push that champion model to production, and we begin to retrain other challengers till we find another one that is better than the champion, and we push that also to production again, and that cycle pretty much repeats itself. And there's a manual way of doing all of that, and we can also set up like an automatic way, which is continuous integration, continuous deployment, where things just go from us experimenting locally, and then if we are able to find any breakthrough that makes the model better, we push that to production. So this is still loading. While this is loading, let's just begin writing the fast API part. So we need to check our pipeline.py here. Everything looks good here. So we have our main here. So I'm going to create three more um, files here. And the first file I'm going to be creating is going to be the schema.py for our schema. If you have any experience about FastAPI, you should already know what this means. But if you don't, then I'm going to have one called utils.py. But if you don't, well, FastAPI is Python's best framework, best web framework for building web APIs for building web. It is not just restricted to APIs. You can really do a lot of very interesting things with it, and it is very very nice. It is a project. This API project that I love so much. It is my favorite Python framework, and I'm not even a web developer, but it is just brilliant. Um, so that's what we are going to be using to wrap our model and serve it to users. So we've created these three things: main.py, where we are going to be writing the main application; schema.py, where we're going to be writing the structure of the model response and the request object. If you already have an idea about what Pydantic is, so FastAPI uses Pydantic a lot. So Pydantic is another very, very incredible Python library for doing data validation. So one of the reasons why FastAPI work the way it does brilliantly, these are started already, is because FastAPI uses Pydantic for doing data validation, type hinting, and stuff like that. So and that's what we are going to be using to set up our uh, our payload, the information that people are going to be sending to the model to make prediction. We're going to set it up nicely using Pydantic, and also the result, the output that we expect to send back to people. We're also going to be setting that with Pydantic inside this schema here. Cool. So another thing that we are going to be doing is just have a predict function inside this utils.py so that we don't just clutter the entire main page. So yeah, let's get into it. So to start, I always prefer starting up writing my schema. So I'm going to click on this schema.py and get into it. So I'm going to say from Pydantic, I'm going to import base model, and base model is what we use to actually create objects. Basically, uh, base models are, that is Pydantic's structure. That is the class that you must inherit whenever you want to create your own Pydantic object. Then you're going to see how that works. Then I'm also going to include field. We use field to actually add metadata to our data, or to our to all of the entries in our objects, inside our Pydantic objects. Then we're going to say from typing import. So we might need to import literal, because in some cases we actually have categorical variables, and literal is our way of specifying categorical variables. You can think of it as enum, like enum if you are coming from SQL. Whenever you have entries that are close bounded categorical variables. So yeah, I think this is cool. So let's start off by creating the root response of root response object. So whenever people hit the home page of the endpoint, like the root, the base page of the endpoint, what kind of message do we want them to see? So I'm going to say class, and this is the way we define this thing object. So I can say root response, and it must, like I said earlier, must inherit this base model, this particular base model here. So it says it's an abstract a base class for creating Pydantic models, like I explained earlier. So if you want to create Pydantic model, you must inherit this particular base class here. So the next thing that I'm going to do is pass in this and add some doc string just to help I used to say this is a clean way of writing code so that your future self or people that are part of your team are going to appreciate you for it. So I'm going to say Pydantic model for the root response. This response, this response gets displayed on the main page, on the main page. Whenever people land on the endpoint main page, this is what they see. So what do we pass in there? What we are going to pass in is the message that we intend for them to see. So I'm going to say message, and that is going to be string, and it is going to be, we can actually add metadata, and that's going to be, we can add description. There are a lot of things you can do with description, and the description is going to be response on the main page, and we can add example, and an example is going to be the endpoint is live, or we can say welcome to the root page. Sorry, excuse me, Ctrl Z. You can say something like welcome to the root page. Then the next thing that I want to do is create the model response object. And model response object is going to be, okay, if somebody hits our endpoint, the prediction endpoint, like predict this, how do we want to present the information to them? How is it going to go out to them? So the way we're going to do that is we're going to say class and say model response, and that also is going to be a, a base model. It's going to inherit from base model, and we are going to add our dog string and say Pydantic model for the prediction results displayed to the user. This is the structure of data that the end user sees, something like that. Then, so how do we want this to happen? Don't forget that this is, okay, let me close this up for now. Don't forget that this here, let me add more here. Select all and say apply. Okay, great. Don't forget that this is how the outcome is expected to be, right? So it's going to be loan status of approved or rejected. So loan status is either going to be approved or rejected. So this is what we want to see. So how do we do that? We're going to come here and say decision, and that is going to be, well, if we say string, yeah, we did message and we did string. Message could be anything, right? Welcome to the root page, welcome, we are live, we are open. But decision cannot be anything. Decision can either be approved or rejected. So we cannot just pass string here. It will mean any string will fly, but that's not what we want. So That is where literal comes in. So we're going to say literal, that is, it must be one of either approved or rejected. Either approved or rejected. And we are going to say field, and field is going to be dot dot, and we can pass in description equals models. Okay, let's maybe take this to the next line also so that we have more screen real estate. And I'm going to backspace this all the way up, then do this. Yeah, model decision on loan application. Then another thing that I want to pass in is examples, and that is going to be either approved or not, which is going to be rejected. Perfect. So this is for the model response, and the um, real work now is going to be to create the model request. You're going to create the model request object, and that's going to be class model request, and that is going to also inherit from base model. And this is the part where we actually structure the way we want to give information, the data that the model needs for prediction, the way we want to give it to it. So I'm going to say pydantic model for the payload that the model needs for making prediction. This payload basically um, aligns with the data, the structure of the data of the attributes or features or columns that used in the training data. Perfect. Great. So what we are going to do is we are going to come here and list out, or maybe just go to our pipeline. And here's our pipeline here. It has nope, this place it has executed, and these are all the columns that we have, right? So number of the, and this is exactly the way it is. But what we are going to do is we are going to go into, oh great, we've already done it. I wanted to say we should get out some columns, right? So we already have the columns listed like so, like this. And so I'm just going to copy this. Oh, sorry, I mistakenly used Control C. So let me just CLS that, and or maybe not, since all I want to do is just copy stuff. So I'm just going to copy this. I think loan status is not part of it. So this are really like everything that we need. Then we are going to come to, where is that again? Yeah, we've copied this. Yeah, so we'll come to this place. We'll come to schema.py. Great. Come to schema.py here, and we are going to, I'm just going to like add a multi-line code here and paste all of this. so that I can, use it to structure my stuff. So I can also look here and check for each of those columns number of dependents. We're starting with number of dependents, so that is integer. So I'm going to come here, copy number of dependents, or I can just typing is probably going to be better. So I'm going to come here and say number of dependents, and that's going to be integer, and it's going to be equals to field, and like this. Description is going to be the number of dependents. And we also can pass in example. Is important to always pass in examples. So we can do something like 3 comma 5, and we can also do greater than or less than. Let's say there is a maximum value for, you know the number of dependents that the model saw. We don't want to go above that, because going above that will not make sense. So what are we going to do? We're going to say must be less greater than. First thing is, you cannot have negative dependence. So we're going to say must be greater or equals. Let's use greater or equals. Must be greater or equals to 0. That is, must be from 0 upward. Then another one is that maybe you cannot, I don't think anybody has more than 100 dependents there. You want to also do that so that people don't start passing information that is, let's say maybe 30, that goes out of training data, so that your model is still going to make um your model is still going to make prediction, but then it's going to be some prediction that probably it has never seen before, or something like that. Now, what we want to now do is we want to do the same for majority of the things here. So I'm just going to copy here and paste, and here's what I'm going to do, just so that this video does not get extremely long. I have to do for each one of these guys 1, 2, 3, 4, all of this. So I'm going to pause it and fill it up and just explain the idea behind it. It's simple. The only thing I'm going to be doing is I'm going to say education equals, I'm going to check whether it is string. For example, I'm going to check for education. Education is a close bounded categorical variables. So graduate, not graduate. If you click here and say yeah, full, it's just graduate and non-graduate. So I'm going to change that to literal, then just write for each one of them. All these ones will be floats, probably. This one will be integer, but you don't want to sit through working through the whole thing. But when I'm done, I'm going to show you what we did, if I did anything different. Yeah. Yeah, we are back. So I filled in everything, although some of them are placeholders. So for example, um income per annum, you know, the examples here, I'm not very sure if it reflects what is in the training data. So we're going to just check that. Let's refresh this page. Don't know why that went off. Still coming, still coming. I just want to get a glimpse of, some things that we can pass in. Okay, cool. So for example, annual income is from 200K, right? So we could probably pass something like that, maybe for 200K to 9 million. So in your example, you want to do, what did we just check? We just check um where is it? Annual income of the applicant. So this income annual. So yeah, I think this reflects it nicely. There's no problem. You probably want to do greater than 100K. Maybe just greater than 100K. Is that 100K? Yeah, that's 100K. So loan term also, but the one I'm actually interested in is this residential asset value. So we'll come to residential asset value. Residential asset value. Uh, Actually, it goes back to negatives. So we want to fix that. That is negative 100,000. So residential asset values must be greater than or equals to negative 100,000. Something like that. From that upwards, then commercial, I think this residential asset value gets to 29 million. So what we gave it as example, so will probably will suffice. Just give it 240,000, something like that. Yeah, maybe something like this. Then commercial asset value, let's check that. Commercial asset value starts from zero, zero, yeah. So that's cool too. Commercial asset value. I'm gonna copy this and just paste it here. So we have luxury asset value and bank asset value. So those ones are not captured yet. So we just need to come to this place and say select all, click apply, and bank asset value started from 300K up to 39 million and 0 to 14.7. So that is cool. But the example here, they are not good enough. So we can just do 700. That is 4.547 million. Then we can do maybe 750,000. Just examples, right? Then we can just maybe pass in 110.4 million like that, and maybe 47 470,000. 470,000. So yeah, that's everything. And where we had categorical variables, let me see if we are running. Yes, we are running. So where we had categorical variables, we actually added literal there. So our job here is done. The next thing we need to go to is come to utils and write the function for uh, actually doing prediction. So we're going to say from sklearn import, just import random forest. Sorry, from sklearn dot ensemble import random forest classifier. We're going to import pandas as PD. We are going to say from, we are going to actually import login. We're going to import login. I'm going to say from login import, we're going to import get logger. We are going to say we need ZenML, but we are going to go copy that. Then let's just configure our login. And how do we do that? We are going to say login dot basic config. We're going to set the label to login dot info so that we start tracking that from info. That's the only thing I'm going to do. And I'm not really going to customize the log too much because we are going to be sending that to Logfire. So inside our FastAPI application, we're going to use something else to handle the log, which is Pydantic Logfire. But another thing that we want to do is we want to say logger equals get logger, and we go under name so that we track log in this particular file. Then that is great. The next thing we would do is set up the function that actually returns all of the artifacts that we need. So what does that mean? Here's what it means. If you come into our pipeline, so what we are going to be needing to deploy the model, actually, they are the artifacts that we used during the training that correlates with the pipeline that returns the best model. What do I mean? So if we come to pipeline.py, we're going to return this model, which is the model that does prediction. We're going to get there's a problem here. We need to return this scalar. We didn't return scalar, so we need to return scalar. Okay, we did return encoders here. So firstly, we need to fix something in our pipeline. We go to this scale underscore data set steps. So I'm going to come into step data cleaner and come to scale underscore data set. Where are you? So I can firstly add it here and say comma annotated optional of standard scalar, and that is going to be scalar object like so. Yes, that is perfect. Especially one type of, okay, that's cool. I think that's done. Yeah, that's cool. We just need to come to this place and say comma scalar. Great. So we have x train, x test, and scalar, which is our standard scalar here. This one here. If you want, you can start off with scalar equals none. And do like scalar equals none, something like that. So that if there's an error, we don't get anything. And if there is, we get a standard scalar object or none. Great. So the next thing we are going to do is come into the pipeline here. And now this does not just return, where is it? Scale data set doesn't just return extra instances, it also returns the scalar object. Perfect. So we're going to grab this encoder, we're going to grab this scalar, and we're going to grab this model from the pipeline, and we'll run that. And that's what we're going to be using for making our prediction. So if we come into this place, so this particular step, uh, encoded split dataset has finished. We didn't have any run that completed the whole thing. That's interesting. Let's go check our training.py. Okay, here's the thing. We are going to come to pipeline, the CMD here. Let's cancel this whole thing and run the pipeline again. Then once that comes outside, like once the pipeline runs, it should get us up to, if everything works correctly, it should get us up to returning training and test value here. So if that happens, then it means we are good. So while we are waiting for it to run to finish, we can go to our main.py and start writing the main FastAPI application. So I'm just going to remove all these things here. So I'm going to say from FastAPI, I'm going to import FastAPI. I'm going to say import UVCon, which is the server that we're going to be running on. Another thing that we're going to need here is the HTTP exception. I'm also going to be needing the status for HTTP status code. Then we don't need this anymore. What we need is UVCon run, and I'm going to run the main app, and port is going to be equals to the port, which is the default port, it's 1000, or let's just do 8080. Then host is going to be equals to localhost, and reload so that it gets all the changes in real time. So what other thing do we need? We need fast API. So we're going to say from schema, we need to get all of those models in schema. We're going to import, we will import root, what we name the root response, root model response, and request, model request. Yeah, those things. Let's check if this is done. Great, this has executed. So let's see if it gets to training the model. Okay, it's still on, it's not done. Still encoding. That took okay. I think encoding has finished. So let's go back to main.py. So root response, model request. What other thing do we need? We are going to need Logfire. So I'm going to check if I added Logfire here. Yes, I did. So Logfire is what we're going to be using for tracking all of our uh, interaction with the API. So it is called monitoring or observability. Anyone. So let's say import Logfire. And for now, okay, we are going to need .env. So let me check if we have .env in our pipe project.toml. We don't have .env currently, so we are going to add it once the job is done. Once the job in this UV, in this command line is done. So I'm going to say from .env import load.env. Then we can come here and say configure the environment variables and monitoring. I want to do both together. So we're going to say load.env like this. Then we're going to say our logfire token. We haven't set that up, but we are going to do that. It's going to be equals to OS. Did I import OS? No, I did not. So I'm going to come here and say import OS. Then I'm going to say, excuse me, os.getDNV, which is how we get the environment variables. We have not created the environment variable, but we are going to do that. os.getDNV logfire token. So this logfire token, we are going to actually go to logfire and create a project and then grab the token. So the next thing we will do is this is done. So we're going to come here and we're going to initialize the app. So to initialize the FastAPI application, you only have to do app equals FastAPI like this, and you can add majority of a lot of things here. You can say title equals loan prediction ML uh, app, something like that. Then you can add version. A lot of things that you can do here. There are a lot of things that you can do here. Version, let's say V1. So yeah, you can do V1 / base like this, meaning this one has the base model. Anything you want to do, you are really, or you can do V1-base like this. You can really do. Then the next thing to do is to actually instrument and configure logfire. So instrument, we've already said that is what we are doing here, sha. So I just do logfire config. I can say logfire.configure, and in there I can say token is going to be equals to logfire token, and what's that? We are going to instrument our app. So we're going to say logfire dot instrument. So FastAPI, we come here, instrument FastAPI, and we are going to say app equals app. Or you could just do app. So that is that. We have instrumented that. The next thing that we want to do is we want to create the root endpoint. So I'm just going to say at app.get, and that is going to be our path is going to be the root. Then we can say tags, and that's going to be the root, or you can just call it the home. Then we can say def or async def, since this is the home page. So FastAPI supports async await, asynchronous programming, a way for you to actually write concurrency into your web application. But If what you have is a machine learning application, that can be very tricky. Can be very, very tricky. So, um, especially, for ML, I like to be honest with myself. So, you're an ML engineer. There's nothing wrong with actually getting more knowledge and all of that. So, if you want to commit time into actually learning asynchronous programming, stuff like that, it's cool. FastAPI has a very good documentation on that. But even if you do learn it and you are good with it, you are really going to be better off not including async in ML application. And I think it's also on FastAPI's own documentation. It is inside the documentation. If it is something heavy, something ML kind of thing, you probably should just use def, ordinary def, no async, right? But if it is simple input output, just displaying stuff, doing simple CRUD, which you are going to really do as a machine learning engineer or data scientist, you are going to really do that. So that's async is going to work for that. So you can just always use def, right? So this is the home page. I can say def root, and we are going to go. That does not take anything, and it is going to return. All it returns is simple. It's going to return the root response, and our message is going to be equals to we are live, something like that. Yes, so and you can also add doc string here. You can add doc string here. I'm sorry, not here. Here you can actually do response model is, and that is going to be root, excuse me, root response. And here you can add doc string again. You doc string will never port, so you can say and let me say this endpoint is the root endpoint that gets opened or that gets called first time the app is launched. Something like that. Yeah. So that is cool. Next thing to do is we're only going to have two endpoints here, really. So it's just going to be the root endpoint. And the reason why we have the root endpoint is so that whenever you land, whenever you make call to the page, you don't get to see not supported or something like that because you didn't define this part. So second one is going to be at app. That's going to be a post request, and I'm going to say path is going to be equals to uh, predict, and yeah, so tags going to be equal to loan approval. Or we could just call this one get approval. Get approval. You can name it anything. Get approval. And the response model is going to be model response. Great. And here we're going to say def, not async def now, just def. Let's check if this is done. Where are you? Yeah. Yes, it's done. So everything has finished there. And what we are going to do really is we are going to say uv run ZenML login dash dash local dash dash blocking. If you that's if you I'm on window currently, so you on window you have to always do dash dash blocking. So it's going to spin up our pipeline, and we're going to go grab some artifact ID there. But let's get back to our main.py. So I can say def, and we can call it predict. And what is it going to take? It's going to take a payload, which is the payload that we've already defined inside our schema. And the payload is going to be model request. model request, this one, and I'm going to go add doc string here and say this is the main endpoint for predicting loan approval. This endpoint takes a payload of applicants' data and returns a decision on their application. Good. So we can come here and we are going to actually let's do pass for now, because we haven't defined what we need to do inside this utils.py. So let's go to UV, and our what do you call it? Our pipeline has already run. So we're going to click on that. Where is it? I'm going to hold control and click on this. And once we do that, we will discover it's still coming up. Let's actually inspect. Yeah, I think it's up now. Should be up now. Perfect. So we are here and click on default, and I can click on this default here and loan pipeline. This is loan pipeline here, and this is the last run. The time currently is 10:53, so the last run that went through was 10:41. So if I should click on that, I get this diagram that I had already shown you in the last one. So if we look at the things that we're going to be getting here, that we're going to be copying are: one, this label encoders object, this one here. We're also going to be copying this scalar object, and we're also going to be copying this base model. So how can we do that? If we click on this label encoders and come here, right, this piece, we can just copy this whole thing and go into our project here. We're into these utils and paste this. I'm just going to say from ZenML.client inside these utils, do this. Then I can remove this here and say Ctrl X. So I can come all the way down here, and first I have a function for getting artifact. So I'm going to come here and say def get underscore artifact. Artifacts, and it is going to take nothing and return. It's going to return a tuple. So I need to come here and say from typing import tuple. I can come here and say tuple. Actually, I need a couple of other things apart from random forest. I need from sklearn dot preprocessing. I'm going to import standard scalar and also import label encoder. Then I can come here and say tuple of label encoder, standard scalar, and random forest classifier. So these are the three things that this guy is going to return. Maybe let me take this to the next line and end this. Then I can actually have artifact underscore URI. So then that's going to be a dictionary. So the first one is going to be encoder, and that's going to be equals to some string that I will paste later. Then the second one is scalar and that is going to be equals to some string that I'll paste later, then model, and that is going to be equals to some string that I'm also going to paste later. So once we have all those, I can actually just check my log here and paste this particular thing here. This artifact equals this, so I can tab this in. So what I'm really going to do is I can get for each of those artifacts. That is, there's one artifact for encoder, there's another artifact for um, what do you call it? The next one. So I'm going to just say I can actually make a loop. So I can have an empty tuple. So I can say artifact, let's call it list. I'm sorry, an empty list rather. Artifact list. So I can say for artifact in artifact list, for artifact in artifact URI dot items, for artifact for artifact URI in artifact URI dot items like this. Why is this guy still showing us an error? Encoder is not defined. Hold on. What's the error? What's this one suggesting? Function with declare. Okay, that's different. That's why this one encoder is not. Okay, let's come here and say return tuple artifact list. I need to clear off that error that we're seeing earlier. So this new error here, it says encode. Oh, that's true. This should be what do you call it? A string, not a variable model like this. Perfect. So we can now come and say artifact underscore list equals empty list. So I can say for artifact in artifact.uri.items. So I can do this. And for the first one here, I can tab it in. So I'm going to say artifact equals client.get artifact. And which artifact are we trying to get? For the encoder, right? We're going to get the one for the encoder. So how do we pass that in? We are going to pass in the first one. So we probably don't need to make it a dictionary. We can just make it a list. So since we already know the way it is going to pan out, like the way the order is, so we are going to say artifact underscore URI. I think that's better. And that's going to be, the first URI, which is going to be for the label encoder. Second URI is going to be for, for the science scalar. Third one is going to be for the model. So now we are not doing dot items anymore, and we are not looping through dictionary. It's just going to be one thing. So for URI in artifact underscore URI, what's this? It's not accessed yet. Cool. So all we just pass in is here. We are just going to give it the URI here. Great. Great, great, great. What is this? Undefined name artifact URI artifact. This is artifact. Yeah. So then the next thing we want to do is once we get that particular artifact, we are going to do yeah, this is going to be there. We're going to say artifact object, artifact underscore object, and that is going to be equals to artifact.load. Then once that is load, we just say artifact underscore list dot append, and that's going to be artifact model, artifact object rather. So the next thing that we just, so once we append the artifact object, we are cool. So what that means is it goes for label encoder first, appends it, goes for standard scalar next, appends it, goes for random forest classifier next, appends it. Then we get to this place and we just turn that thing into a tuple, right? So what we need to do now is come to this place here and copy each of these URI, right? But then we need to make sure that everything works perfectly. So let's check our pipeline. So I should come all the way up here, this place, check that. Oh, this thing, these particular columns, these column names, they come with this empty space here. We need to remove it. I think I mentioned it in the last video. We need to remove that. So let's quickly go into our steps and come into data cleaner step. And after loading, and before we split, after loading and dropping, let's check this place again. Let's check UV again. So if we check UV now, where are you? Great. Yeah, we are going to say after load we drop. So we are going to include that line, the line to do this inside the drop columns. So go to data cleaner again, drop columns. Okay. So before we do this drop column, we're just going to add this one line of pandas code that's going to remove um, that particular strip, that leading. We are going to strip that leading empty space. So I'm going to say data dot columns, and that is going to be equals to, if you know pandas, you are already familiar with something like this. Data dot columns, that's going to be dot string, that is dot str dot um I think something like L strip should be here. Perfect. L strip, and we remove that. So yeah. This should do it. So again, we need to rerun the pipeline again. So I'm going to come to this place and remove this, slide all the way down, and just hope to God that that does not take too long. And while we are waiting for it, we'll do something else, and that thing is going to be to get our environment variables. So yeah, let's do UV run pipeline of UI. So inside utils here, I was about to make a mistake here where I wanted to list this thing. We cannot expose all of those information. So we'll come into, that is those URI ID. So we're just going to come here and say new file and call.env. And in here, we're going to create some environment variables. So the first one is going to be model underscore URI. We are going to paste it there. Um, encoder underscore URI. We're also going to paste that there. Then the next one is going to be, what's that going to be? Scalar underscore URI. And we're going to paste that here. And also Logfire token. This video is really getting too long. I hope we are able to quickly set up Logfire underscore token. And that is going to be like this. So I can come into utils.py and just add import os from .env, import load underscore .env, load.env. Yeah. Then we can come here and just say load .env. Why am I not getting suggestion for that? Did something happen? Okay, I guess. Okay, maybe I don't know. Even OS, I'm not getting suggestion for OS, but that's cool. So load.env, and we can just come here and copy. We are going to come to this place, copy these three things that we need. Control C, go into our utils.py and paste this. But we're going to remove that and say os.getEnv, and it is going to be model underscore URI. And I can just copy this and paste, paste, remove these two, and edit this encoder URI and scalar URI. Great. So those are the things that we're going to pass in here. We're going to say the first one has to be encoder URI, encoder URI, scalar URI is second one, scalar URI, and model URI. Great. Great, 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 great. From .env, we do not have .env. So I am going to come to I think everything is cool here. If you ask me, I'm not sure. For URI in URI, string or none. Okay. We can just string it if we are not sure. See str. Exactly. So, .env is here. Perfect. Yeah. So the next thing to do is let's check if this guy is done. We have an error. It says unable to load type. Let's check. Did I include? Let's check our pipeline. .py here. We added scalar here, and what other thing did we change? Well, let's go check the error again. It says unable to load type class pandas data frame. Beauty materializer can only load artifact of the following type. Oh, load int. In what step exactly is that? Let's go check. It says an error occurred. Loan status is not found in axis. After encoding, split. We try to split. Okay, split completed. Scale. Scale. Our scale dataset field. Let's go check the scale dataset. Let's go to pipeline. Okay, so this is what I'm going to do. I'm just going to try and identify whatever the error is. My laptop is about to go off. So let's try and identify whatever the error is. Then I'm going to talk about it, then fix it. And in the next part of this video, I'm going to type out the fix, explain it, and we do the other part. So let's go. The problem is going to be inside scale dataset step. So if we come into our steps, where's our scale dataset? Data cleaner, yeah. So scale dataset. Right. So here, this guy is saying something along the lines of I cannot find. Let me remove this data loader, remove this training, remove pipeline, schema, and utils too. So here it says an error occurred detail loan status with this um, line not found in axis, and that's because we have already removed this strip. We've stripped this thing. So I think so, yeah. So if you come to data cleaner, and this place, this is going to be the fix where we say x equals something, y equals some other thing. Yeah, do we have that? We should, else we are doing this wrongly. Oh, okay, it is where we splitted. Perfect, this place. So just remove this line here. Yeah, perfect. So that is the fix. But since we are not getting battery low yet, let's just quickly run that and CLS this, then run that and wait to see what happens. It's probably going to go through. It's definitely going to go through. So, but the moment we still have 15 minutes on the clock, and our run is has started again. Still going. Worked up to data loaded successfully, and dropped columns. You're going to see that all those things are gone now. Those extra leading spaces, they are gone. So the data is looking exactly the way it looks inside the schema.py, the same way it is here. Yeah, I think the battery is low. So what we are going to do is just observe this run all the way, still encoding. Oh, still saying split dataset loan status. I thought we fixed that. We have fixed that, but I'm guessing maybe we have some kind of cache running. And let's go check split dataset again. Where are you? This is a bit risky. I do not want to lose the recording. So let's go check data cleaner again. I think there's a part where we did not fix. Yeah, I'm just going to look for. Oh, this is it here. This second one, we didn't remove it. So that's that. But I'm just going to end the video on this note, and I'm going to catch you in the next one. And we're going to continue and finish this up. So thank you very much. See you in the next one.